Okay, so when we're solving systems of equations using substitution, um, it's the same process that we're going for all these problems. We're just trying to use two equations to find two variables. So we're still, just like with graphing, with elimination, we're looking for a value for x and a value for y, but we're going to use a little bit of a different approach. We're basically going to take one of the equations and plug one side of it back into the other one. So in this case, we've got, the problem's kind of a giveaway on this one. We've got an x completely by itself in this equation. And then we've got a more usual looking complicated equation over here. So what we know to look for when we see something like this is that we say, hey, look, we've got the x completely by itself equal to something on the other side, which we can easily take and put into the other equation. So since we know that x equals 2y, we can go take 2y and push it into the other equation so that we can rewrite it with nothing but y's. And so check out what that looks like. So since we know x equals 2y, we can say that goes into the equation here at that x. So we just rewrite it with the new replacement. So right here in the parentheses, we'll put 2y because we used to have x in that spot. So we had negative 4x plus 11y equals 15. So we would put that here, but we're going to leave that x out, and we're going to put 2y in there. So that way we've got a new equation with nothing but y's in it. So guess what we're about to do now? We are going to just simply use the tricks that we know how to do with distribution and combining like terms and all that stuff, and we are going to solve this equation down and get a value for just y, and that's where we're going to put this answer in there. So we know that we can distribute this negative 4 over to the what's inside the parentheses. So we're going to get negative 8 when we do that, because negative 4 times 2 is negative 8. So we'll have negative 8y plus 11y equals 15. And we don't have to add or subtract anything from either side. We've got all the y stuff over here, we've got all the number stuff over here. What we do have to do is combine these like terms, which are a bunch of y's. We have negative 8y's over here and positive 11y's over here. So you guys should know by now that when we're adding these two types of numbers, we've got a bigger positive number, a smaller negative number. So we're going to wind up with combining these together into a positive number, because we've got 3 more positive numbers than we do negative numbers. So all the negative numbers take some of these y's away. So negative 8 plus 11 is positive 3. So positive 3y equals all the stuff over here on the other side, which is just 15. So to finish off this part of the expression, we just divide by 3. Both sides divide by 3, and that will give us y equals 5. So we can put that here. Okay, cool. Now that we have figured that out, we should take that value of 5, and maybe I won't erase it, but leave it there. We take that value of 5 that we just found, and we plug it back into really either one of these equations in order to find out what x is. So we can put it in the bottom one, all right? So we can put it in here, because that will give us a pretty easy path towards figuring out what x is. We could put it in the top one, but see how that's a much more complicated expression. It would take us a little while longer to put it in there, and maybe I'll do both of them just to show you, just to prove my point. But if we just want to get this one done quicker, then here, and I know that's always what you guys want to do, we can go ahead and plug it into this equation, just like we did the last one, put some parentheses there, and so we had, the old equation was x equals 2y. Well, now we'll just leave some parentheses and we'll put what we know that y equals. So since we know that y is 5, we'll just put 5 in the parentheses. And now we know that 2 times 5 is really just 10. So we know x equals 10. We can put in here just to prove it. I'll show you that I know what I'm talking about. Well, let's plug it into the other one. Let's say we didn't notice that we had an easy one. And we messed up and we put it in the hard equation to solve. So we'll go ahead and write out everything we're going to get ready to solve, and right here is where our y value goes, so that's where we would take this value and plug it in, because that's where the y used to be. So we're going to finish out our equation. Instead of putting y in there, we'll put 5, so that way we can get ready to solve the equation so that we can get a value for x. We know that this 11 distributes over the 5 to give us 55. And that equals 15 over here. And equals negative 4x. Alright, so we're solving for x. We need to get x by itself. So let's move this 55 over. You can see this is already getting complicated. Fix my 5. So that will give us, taking this off, we'll have negative 4x over here. Let's see, that is what, negative 40. Alright, negative 40. And we'll divide negative 4 of both sides. Alright, and check it out. Now, like I said, we can still do this. It still works. But we got to do a lot of complicated stuff in order to get here. So this negative 4 and negative 4 cancel. Over here we've got a negative 40 divided by negative 4, so there's two positives there that cancel. Alright, and that, when you do 40 over 4, that'll give you 10, which means that we got the same answer. Either one we plug into, either equation we plug back into, got the same answer.